I want to show you how to use an online financial calculator. And I actually personally believe that the simpler these calculators are, the better. Some people will try to customize them for certain situations, like how to calculate your mortgage. But I'm just using a very basic time value of money calculator, and I'm going to show you how to adjust it yourself to find different things. So what I want to do is work those 5 practice problems, or maybe there were 6. Um, nope, just 5. So the 5 practice problems that I had in the 4th time value of money lecture. So if you look at this financial calculator, you can see that there's a way to adjust your time periods from annual to semi-annual and so on. But if I were you, I would always leave this at annual and just manually adjust the rate and the number of time periods because different calculators work different ways. Some, even if you switch it to monthly, you still have to type in a monthly number of periods. In my mind, if I were programming this calculator and I set this to monthly, setting it to monthly would adjust the number of periods and the rate as part of the programming. But I didn't program this calculator, so I didn't get to decide how it works. So and because different programmers think differently, I would personally just, again, always keep it at annual and then manually adjust the rate and the time period for non-annual periods. Okay, so the and that's the way I'm going to uh, work it in this video. So with the practice problems, the first one says 5 years ago we bought a house for 300,000. We sold it today for 387,000. I wanted to know what annual rate of return we earned. In this particular case, we're solving for the rate. So we do know the present value, that's the price we paid for it. We know the price we sold it for, 387,000. There were no payments involved, no annuities involved in this particular question, and it was a 5-year time period. And again, we want the rate. Um, Most financial calculators let you input inflows and outflows. I'm not sure how this one works, so I'm going to go ahead and compute rate, and it basically says it can't compute the rate because I didn't tell it which of these cash flows was an inflow and which was an outflow. So putting it in the perspective of, actually, let me backtrack a little bit. The reason it needs an inflow and an outflow is we were asking it to calculate the rate of return on an investment. We need to tell the calculator how much we spent on the investment and then how much we got back on that investment. Only then can it calculate the rate of return. Well, we spent the 300,000 on the investment. So I'm going to make that 300,000 negative. We received 387,000 on the investment once we sold the house, so I'm going to leave that positive. So the cash flows I'm paying, I'm making negative. The cash flows I'm receiving, I'm leaving as positive. Now it should be able to find the rate for me, 5.22%. So I pressed rate. I don't know if y'all saw that. When I pressed rate, it popped 5.22% into the box. And when we had worked this using the interest factor tables, it had said the answer was between 5 and 6%. Now, what would be lovely if there were just a reset button that I could set all these variables that I just typed in to 0, but they didn't program it with that. But I think if I just press reload, it will reload it and set everything to 0. Now the second problem says if my daughter never adds another penny to her retirement account, she should have about 1.4 million in 50 years. And how much is that worth in today's purchasing power if inflation is 4% annually? I've worked this on the interest factor tables, so we already know which ones are present values and which ones are future values. The 1.4 million is a future value. The rate is that 4% inflation. I'm always going to leave this on annual. This is an annual question anyway. And then I want to know if that 1.4 million is 50 years into the future, how much would that be worth in today's dollars? So I'm after the present value. And just to give the benefit of the doubt. I'm trying to make sure. Basically, I don't know if I leave this payment cell blank, if it will work or not. I'll try it. Oh, no, I pressed the wrong button. I didn't mean to press payment. I meant to press present value. Okay, so I can leave unneeded variables blank and it will still work. Or I could have inputted a 0 there as my payment and solved for present value and it still would have worked. Now, basically then it's saying if my daughter has $1.4 million in 50 years, that has a purchasing power today of $196,997. That agrees with what we got when we worked it on the interest factor tables. Notice it's giving me a negative 196,000. That's because your calculator will always return the opposite sign of the amount that you input. Since I input a positive 1.4 million, it's returning a negative present value. That goes along with if I were solving for a rate or even for a time period, if I have to have a sign change. So anytime I'm solving for a rate or a time period, I have to have a sign change in these dollar amounts over here on the left. By sign change, I mean one of them has to be positive and one of them has to be negative. And I always think that it's easier or best to make your outflows negative, the inflows positive. I'll work one actually I think I'll work one right now. This is not a practice problem uh, that I demonstrated in the fourth lecture for time value of money. It's just one I'm making up on the spot. So let's say that my daughter inherited 12,000 today. She puts in an additional 1,000 a year, and she ends up with 2.5 million 50 years down the road. So she puts in 12,000, she puts in another 1,000, she puts in a $12,000 lump sum, puts in another 1,000 every year for 50 years. She ends up ultimately with $2.5 million. My question is, what rate of return is she earning on such an investment? That would be really difficult to figure out with the interest factor tables. But with the time value of money calculator, it's super easy. If we group cash flows going in the same direction with the same sign, the 12,000 and the 1,000 are both going the same direction. My daughter is depositing that money into an account. So I'm going to say it's leaving her hands. And then eventually, 50 years down the road, she will receive or have an account worth $2.5 million. So that would be money that she could then take. So I'll make that a positive inflow. But notice the two values that are leaving her hands, I'm making those both negative. And so now I can just press rate. So if she could earn about 10%, she could have $2.5 million. But notice if I made the 1,000 positive and the 12,000 negative and the 2.5 million positive and I solve for rate, it gives me a completely different answer. This, the way I've set it up right here, isn't reflecting what's truly happening. So you've got to make the cash flows that are going the same direction the same sign. I wouldn't actually give a question like this on the test because I don't require that you have time value of money calculators. And this one's too difficult to work with interest factor tables. But it's very relevant for real life. So if I were you, I'd learn how to use these time value of money calculators. And see, this is, a great thing for my kid to know. If she puts in $2,000 a year, which isn't that much, hopefully she'll be able to come up with $2,000 a year. And if she can only earn 8%, let's say, after 50 years, she should have $1.7 million. But if she puts in $3,000 a year, she should have a little over $2 million. If she can earn a 1% better rate, she should have $3.33 million if she saves 3,000 in addition to the 12,000 she's already put aside. Okay, but back to the practice problem. So the third question says if you finance a car loan over 4 years with a rate of 12% compounded monthly, calculate the monthly payment if you borrowed $18,000. So even though we're dealing with monthly compounding, I'm going to leave this at an annual uh, time period, and I'm just going to adjust my rate. So my rate is 12% annually, but it's a monthly problem, so I'm going to divide it by 12 months. So I'm going to enter a rate of 1. It's a 4-year time period, but we've got monthly payments, so 4 years times 12 months gives me 48 months. I'm borrowing $18,000, and I'm after the payment. So I don't need to enter anything in the future value cell, but I need to decide which one to press, because when I press it, it computes that particular one. So am I trying to solve for the future value or the payment? I'm trying to find the monthly payment. So there's my minus $474, which agrees with what we calculated already. Now, again, it's giving me a negative sign in front of that payment because I input a positive sign as the present value. For the fourth problem, I'm trying to figure out how long my money will last. So I've saved $2.5 million, so that's my present value, and it's earning 2% annually. I'm taking out 100,000 a year. So since I'm remember when I'm solving for either of these two variables, rate or period, on the left, I have to have a sign change. At least one positive number and at least one negative number. I don't have a future value in this particular problem, so I can leave it blank. Basically, I'm assuming if you leave it blank, it presumes you input is 0. That's probably what it's doing. So my sign change occurs because I input my present value as a positive, my payment as a negative. So now the calculator knows, hey, you've got $2.5 million. You're going to take out 100,000 every year. What you haven't yet spent is going to earn 2% a year. So how long will your money last you? So now we're solving for the period. So I press periods, and I get 35 years, which agrees with the answer we got when we worked it using the interest factor tables. Now, I don't know what it's going to say for question number 5. Number 5 was the same as question number 4, but the difference, with one difference, and that was we're earning 5% on our money now instead of 2%. And I showed you in the fourth time value of money lecture that we would never actually run out of money. So on financial calculators, what usually happens when you try to solve this problem is it gives you an error message. I don't know what it's going to say on this financial calculator, but so I'm going to just delete that because that's what I want to know, and I'm going to press periods. Oh, and that's kind of cool. I like that it says infinity because that's what's really happening. I'm never actually going to run out of money, so my money will last forever. So it's kind of neat that it shows that. I don't mind at all if you use this particular time value of money calculator on the exam. Um, the only issue is if you enter things wrong and it gives you the wrong answer and you miss the problem, you're just going to have to live with that. Remember, and if I were you, I would always keep that annual. I can't emphasize that enough.